Welcome to Algebra 2. This is Chapter 5.9, Transforming Polynomial Functions. So if you recall, we have dealt with transformations in the past. Examples of transformations are translations, where you move the graph to the left or to the right, or you could move the graph up or down. There's also stretch or compression, and that will make your graph tall and skinny, or short and fat. And the other kind of transformation is a reflection. So that's where your graph can be mirrored across the x or y axis. In your equation, your transformations can look like this, where you have your A, which can show a reflection if it is negative. It can show a stretch if A is greater than 1. And it can show a compression if A is between 0 and 1. If you have a number in with your x, it will show a translation to the left or to the right. If you have a number added on the outside, that affects your y, which moves your graph up or down. Now this is true for any graph, so we have done absolute value graphs, we've done squares or quadratic graphs, and it's true for any other polynomials as well. So you'll see it in this section written as a and f of x minus h plus k, where f of x is your polynomial function. So for example, like in got it number 1, we have our polynomial y equals x cubed. That's known as your parent function. There's nothing added to it. There's nothing subtracted, multiplied. It's just a clean x cubed. So it's called your parent function. So in example number 1, they want you to show a vertical stretch by a factor of 2, a horizontal translation to the left by 3, and a vertical translation forward down. Alright, so recall that we have y equals a x minus h cubed plus k. So what value goes in for a? Well, that will be your vertical stretch by a factor of 2. So a is going to equal 2. Your h, we're going to the left 3 units, so our h is going to be a negative 3 because we're going to the left. And k is a translation forward down, so we are going down 4, so that's minus 4 as well. So let's plug these values in. So we have y equals 2 x minus a negative 3, so that's going to be x plus 3. Don't forget your cube because that's the original function, and minus 4 on the outside. And that's your final answer. I'm going to show you what that looks like in a graph. The next section on your notes has a graph, but it's not of the equation that we graphed. Well, everything's just different about it. So I'm going to show you on this calculator here. So on the top I plugged in our new transformed equation, so 2 parentheses x plus 3 parentheses cubed minus 4. And our second equation is our parent function x cubed. So I'm going to show you how these differ from each other. So if we graph it, the first one is going to be the transformed one, and the second one is your normal one, or your parent function. So your parent function crosses the origin at 0, 0. And if you notice, your translated one definitely went down and to the left, but it looks a little funky as well, and it's because it's been stretched. And got it, number 2, we're going to solve for the zeros. And what that means is where your graph crosses the x-axis, or it's when y is equal to 0 and we solve for x. Like so in quadratic equations, we've done this by factoring, graphing, quadratic formula, that kind of thing. Well, here we have the cube exponent, so we aren't able to do any of those things to solve for the zeros. But this one is actually pretty simple. What you have to do is set y equal to 0, so let's plug in 0 for y. And we are going to solve for x. So the whole objective is to solve for x. So we're going to work backwards. We need to get x alone, so we're going to subtract 6 across. We can't do anything in the parentheses yet, so we need to get rid of that 3. Right now it's being multiplied, so the opposite would be division. So let's divide that across. Whoa, sorry. So we have negative 2 equals x minus 1 to the cube power. To get rid of that cube there, we need to take the cubic root. Whatever we do to one side, we do to the other side. So that gets rid of our power. So we have the cubic root of negative 2 equals x minus 1. And our last step is to add that 1 across. So we have x is equal to, and this is our 0, the cubic root of negative 2 plus 1. Let's plug that into our calculator. So to get the cubic root, you go to math, and then down to number 4, it has that 3 out in front of the square root sign. And then let's plug in negative 2, and then add 1. So your answer is negative 0.26-ish. Got it, number 3 will be the last thing we do for your notes for 5.9. So it asks, what is a quartic function? First of all, quartic, that's to the 4th power, with only 2 real zeros, x equals 0 and x equals 6. So there's a little bit of review with this problem, and that's why I like it. First of all, quartic, you have to remember that that's the 4th power. And with that, if we have something x to the 4th, that means it's going to have how many zeros? It's going to have 4 zeros. So you are only given 2 real zeros, which means there's 2 non-real zeros, or imaginary. And the way we solve for our function is if we're given the zeros, remember we work backwards. So if we're given the zeros, then the next step is to plug those into factored form. And then the next step is to FOIL and get your equation. But before we can do any of that, we need to figure out what our 2 non-real zeros are. Well, basically, there are multiple equations that you could do for this. There's not just one equation that crosses the x-axis at 0 and 6. There are all sorts. So they just want one. So what you are going to do, first let's put these into factors. So x minus 0, x minus 6. Remember we flip the sign when we go to factored form. And then because we have 2 non-real answers, we're going to plug in a factor that would give us non-real answers. And the easiest factor to use is x squared plus 1. I'll show you real fast how that'll give you a non-real answer. So if we had x squared plus 1, and we set that equal to 0, subtract 1 across, now you have x squared is equal to a negative 1. Take the square root. What's the square root of negative 1? Plus or minus I. So that's the easiest way to get your non-real answers. Alright, so now we have our factored form, and we have 1, 2, 3, 4 x's. First of all, simplify if you can inside. So this x minus 0 can be simplified to x. and then you FOIL. It doesn't matter which two you start with. Because we just have an x on this one, I'm going to start with the first two. So we have x squared minus 6x. And then bring that last one down and FOIL again. So we have x to the fourth. Wait for it. X to the fourth plus x squared. Oops. Minus 6x to the third. When you multiply, you count the exponents. And then minus 6x. Get that into standard form, so they should go in order from largest exponent to smallest exponent. And that's your final answer. And that's where we're going to stop for the notes.